In the last session, we discussed the just theoretical concept of inheritance. Now we'll see as completely what is inheritance. Here it is. Already we discussed that inheritance is a concept of create an object using existing object functionality. Create an object using existing object functionality. So that is actually what we call the inheritance. Inheritance. And here different types of inheritance are there. Single inheritance, multi-level inheritance, multiple inheritance, hierarchical inheritance, hybrid inheritances. One by one. Single inheritance. See, one thing important in a parent-child relation is actually a different terminology we can use. Some of the people use parent and child inheritance. Some of the people will use a super and subclass, and some of the people will use a base class and derived class, and some of the people will use existing class and extended class. Whatever it is, the concept is the same. See, in a parent-child relation, in parent-child relation, we can access parent using child, and we can access parent. We can child. We cannot access child using parent. Why? The first thing is why? The first thing. Just consider in the last class we have seen two mobiles are there. iPhone 5s and iPhone 6s is there. So iPhone 6s is the extension of iPhone 5s here. Suppose if you purchase 6s, you can access the functionality of a 5s. But if you purchase a 5s, can you access the functionality of 6s? No. So always we create object for this one and we are accessing this one. If you create object for this one, you cannot access this one. It's not possible. It is not possible. That is. And now we'll see that inheritance, how it will execute. How it will execute. We are taking the class. Class is a parent. First of all, we'll discuss with the class level functionality. In parent, I'm writing one method. Just like a define M1 method, it is just class level. A simple message print parent class M1 function. Parent class M1 function and return. Next, we are taking a class child which is extending from parent. How can we apply a parent-child relation means what? Simply here it is a child of parent. Child of parent. And here it is defined M2. M2. And it is a print. This is child class M2. And return 2. Main class you can write separately. Access class. Or inside the child also. First separately I'll explain. Class, access class. Only just It's a starting point. It is not the concept. Inside we are writing that main. We are writing that main. So first program execution starts with main. Main access class dot main. Access dot main. So execution starts from here. See, just now we discussed that using child, you can access parent functionality as well as the child functionality also. As well as child functionality also. It's like here, parent dot m1 we are calling. Sorry, using child. Using child, we are accessing parent functionality. Using child, we can access child functionality also. These two are class level only. No? Class level means what? Directly by using class name, we can access. So we are calling, like here it is a M1 and M2 simply. M1 and M2 we are calling. So whenever we are executing this, okay. Now here, using parent I am trying. Using parent, you can access parent class functionality. See, no error here. But whenever you try to access child class functionality, child.m2, suppose if you try to access, sorry, using parent, if you try to access child class functionality, you will get error. You will get error. So simple. With the help of child, you can access child functionality and parent functionality. But using parent, you can access parent functionality only, but not the child functionality. So one. Now the same story. Suppose these are object level functions. Self. Now these are object level functions. How to access object level functions? Suppose here, whenever we create object for child, C equals to child, it is a child class object. Child class. And simply C dot M1 parent functionality, C dot M2 is a child functionality. Both you can access. Again, same story. Same story. And suppose if you create object for parent, we can access parent functionality. Okay. Parent functionality. Whenever we are trying to access child functionality error is a error. That is, so here using parent we can access or only parent functionality, not a child functionality. That is, this is simple inheritance concept. And next one, in a parent child relation, whenever you create object for child class, whenever we create object for child class, suppose parent and grandparent is also there. Grandparent also. See, grandparent object will be created first. grandparent, next followed by parent object will be created, next child object will be created. Like this, all the three objects will be created: grandparent, parent, and a child. But remember, three objects will not get different memory locations. Like this is at 2046, this is at 5068, this is at 9008. Like that, three objects will not store in three different memory locations. Only one object will be created. Only one object. It contains grandparent functionality, it contains parent functionality, it contains child functionality also, and only one address. Single object address. Single object address. So why different memory locations objects will not be created means what? Suppose, come to that mobiles only. Mobiles. iPhone 4S, iPhone 5S, iPhone, iPhone 6S. Suppose this is. Whenever you purchase iPhone 6S, physically in your hand, iPhone 6S mobile is there. Physically, this is. But logically, you can access 5S features and 4S features. Logically, nothing but internally, you can access the functionality of a 5S mobile as well as a 4S mobile. 5S and a 4S mobile you can access. But whenever you purchase 6S, physically they will not offer you 5S mobile and 4S mobile. So separate objects will not be created. A single object which includes the complete functionality, everything, everything. That is. How can we prove? Suppose here it is grandparent also we are taking. Grandparent is M1. This is actually grandparent, grand. And next one is a parent M2 and is a child M3. Grandparent, parent, and child. Grandparent, that is accessing the functionality of a parent, is accessing the functionality of parent. So whenever we are just creating object for child, we are calling the child dot M1, M2, M3. All the three we are executing. Just like the previous example, everything will display. Grandparent, parent, as well as a child. Child. Here, here, whenever we are executing, I just want to display the address. What is a grandparent address? Simple example, self. And next one is the parent address. Here it is a self. Next child address. Here it is a self. We are displaying like this. Is actually what we are thinking in a grandparent level. Grandparent address will give. In a parent level, parent address. in a child level, child address. But actually here only one address is there physically. Only one address is present. So whenever we are executing this, look at this, we are giving grandparent, parent and child. But see here it is giving that child object, child object, child object. Address is the same address 580, 580, 580. It's only one address physically. But using that address, you can access the complete functionality in the hierarchy in inheritance concept. That is, this is. And now, one more concept is here it is important concept is method overriding concept. What is that method overriding? Defining a method in the child class, defining a method in the child class with the same name, with the same name and the same signature of its parent class, with the same name and same signature of its parent class. What is that? Suppose in a parent class, this much enough. In a parent class, there is one method. Suppose fun is a fun. This is parents fun. Parents functionality. The same function if you write in the child class. If you write in the child class, same name and same set of arguments also. Exactly. That is what we call the method overriding. That is called method overriding here. This is overriding. And here the question is, sir, whenever you are extending from the parent in inheritance concept, whenever child class is extending from parent class, automatically the parent class functionality will come into child. Automatically, parent class functionality will come into child. That is, that is. Here, then why we are writing once again? Why we are writing once again? Here, that importance of overriding we'll see. Whenever we are calling c dot fun, first it gives the priority to child class only. Child's fun. And here it is whenever we run this, is a child functionality. That is. And here whenever we are accessing this one, parent I want to access means what? Later. First it gives the priority to child. If child is not there, then parent. If child is not there, then parent. Sir, what is the importance of method overriding? What is the importance of method overriding? That is, suppose in the last class we have discussed that the main importance of inheritance concept is 3 points actually. 3 points. What are the 3 points? I'll explain. First point is what? First point, accessing existing object functionality. Second one, adding new functionality. Third one, update existing functionality. This is, sir, what all these things? Sir, what all these things means? What? Here, here it is. We are taking one class, like one mobile. Samsung mobiles we are taking, because one is a very basic version and one is a little bit upgraded version mobile I'm taking. Suppose first of all, the Samsung Guru mobile we are taking. Guru. In that I'm writing functionality. In that I'm writing functionality. Just calling we are writing. Call we are writing. Here just print is a calling, and this is the feature of Guru. It's a Guru mobile feature. And next, upgraded version we are writing. Class, and its Galaxy. It is extending from Guru. Is extending from Guru. See, we are purchasing that new generation mobile means what? Definitely we are expecting the new features from that. So definition is like a video call. Self. Video call. Print. And here it is a video calling from Galaxy. Video calling from Galaxy. Now, suppose if you purchase Galaxy mobile, here I'm creating object for Galaxy mobile. Mobile is a Galaxy. If you want to call, simply mobile.call. So it is accessing existing object functionality. First of all, existing object functionality. This is the one. Accessing existing object functionality is the first one. And next one, adding new functionality. Adding new functionality means, suppose whenever we are calling that video call, and this is video call is a new functionality of Galaxy. See, in a Guru, video calling option is not there, but that option is available in a Galaxy. So when we run this, see, calling is fetching from Guru. That is called accessing existing object functionality. Next one is a video calling means what? It is a new feature of Galaxy. Is a new feature of Galaxy. This is. And now, what is that updating existing functionality means? For example, in Guru, define, there is one option called camera. Just print. Here it is a camera. Just it's a 2 megapixel camera available in a Guru. See, whenever we are trying to access that camera, mobile dot camera. It will collect the 2 megapixel camera from the guru. But suppose imagine the next version means what? Some of the features we have to update of from the existing version. Definitely that is expectation, a people expectation, that is. So here, so here, whenever whenever there is a function camera with the same name, we are not changing the name. With the same name, the same feature we are writing in a guru, in a galaxy also, in a galaxy. Just camera, 8 megapixel cam, we are upgrading in galaxy. This is called overriding. Override means now it is the concept of update, or it is the concept of extends, the concept of extends or update. And here, whenever we are calling that camera, whenever we are calling that camera, and see now the 8 megapixel camera galaxy, 8 megapixel camera galaxy, that is executed. Calling guru, video calling is a galaxy, and camera is updated functionality. So this is actually exactly what is inheritance concept. What is inheritance concept? Simply. And now, and now, here, here, and remaining, for example, hierarchical inheritance is there. Hierarchical inheritance, multiple inheritance, multi-level inheritance, and all we'll see one by one. Now, now in a parent-child relation, in a parent-child relation, class parent, here it is a function is the same fun only, print, and it is a parent's fun, is a parent fun. And now here it is a child, it is the extension of parent, and here also same function, overriding concept only, and is a child fun. Parent fun and a child fun, two are there. Parent fun and a child fun, two are there. Here it is, whenever we are creating, whenever we are creating object for child, c is equals to child, we are, whenever we are calling that c dot fun, it gives the priority to upgraded functionality only, child fun. Give the priority to child fun, that is. And now, and now, whenever we are executing the parent functionality, is a parent class functionality I want to execute. How to execute that parent class functionality? Here we are creating object for parent, parent, and p dot fun we are calling. P dot fun we are calling. And here whenever we are calling that p dot fun, we are calling p dot fun is executing okay, but it is not recommended one. Sir, why it is not recommended means whenever you create object for child class, parent object will be created and child object will be created. Of course, including functionality is a parent object and it is the child object. And here, whenever you create object for parent, once again parent object will be created. It's a duplicate object in the memory now. Duplicate objects not allowed in the memory. Duplicate objects not allowed in the memory. That is. So don't create object for parent class again. Don't create the duplicate object. Just we need to access that parent class functionality. Sir, how to access? How to access? So actually this is the option they have given. This is the option. Whenever you create object for child, suppose is obj, it's a combined functionality of a parent and child. Na? Combined functionality of a parent class and child class. Simply we are calling like this: parent class dot fun. We are passing obj. Child class dot fun. We are passing obj. We are calling just like class level function only. Parent class fun. That obj means what? Self. Child class fun, and here obj means what? Self. Like this it will go. The parent and with the child. It will go like this. Parent class functionality and the child class functionality. And whenever we are executing this one, parent fun and child fun. Parent fun and child fun. This is the way. And now, here it is a, sir, more than one level. Suppose grandparent is also there. Same story. A grandparent is also there. Definition. Definition, fun, self, self, print. This is a grandparent functionality. That is. And is a parent is extending from the grandparent. Parent extending from the grandparent. And same, just grandparent dot fun, and we are passing that obj. When we run this, all the three execute. Because for all the classes in the hierarchy, only one reference, one object is there. That is called obj. It's called what? Obj. That is. This is how it will execute. How it will execute. So this is completely, I mean, like method overriding and how to access this one and all. You are in a class level area. Suppose if you are in a object level area, that is also important. Suppose you are in a child class. First consider in a child class. In a child class, there is one more method consider. There is one more method. Just get one method is there. Object level. Object level. This is class level. Na? Main is a class level. Here every time we are calling obj, obj, and obj we are passing. Suppose from obj we are just calling get function. Get function. Obj dot get means what? It will call this child. Child. Then this obj will store into this self. We know that. Now sir, all these three I want to access here. I want to access here. Then very simple. OBJ is a local, it is available here only. And here, just now we discussed that obj dot get means what? Obj means self. So here you have to pass this self. Instead of obj, self we can pass. Self, self, we can pass. Whenever we are executing this one, no error, it will execute. Whenever you are in a class level area, use object reference variable. Whenever you are in a object level area, use that self. Use that self. That's the difference. That's the difference, right? So this is the one.